Hello. Title of my talk is Mobility Makes Us Happy. And my name is Hirukawa from AIST Japan. I have traveled from Japan by 1 day and a half to here. It's really exhausted. So we can be happier when we have more mobilities. I mean that when we can walk outside, we can take a walk in a park, we can visit our friend, we can go shopping, we can go restaurant. Then this means that when we can go walking outside, we are part of a community. Also, we can enjoy social and civic life. So this is very important. Even when we cannot walk outside, if we can walk inside the house, we can go to the bathroom by ourselves. And still we can be independent. We can have the independent life and enjoy a domestic life with our family. So this means that mobility is a fundamental function to live happily, for us to live happily. So this is ICF. ICF is International Classification of Functioning, Disability, and Health, defined by WHO in 2001. It says that health is sum on physical function, body function, activity, and participation, and these are depending on the environmental factors and also the personal factors. Robotics can be a part of environmental factors to help our health. And here is a question. Can robotics assist the mobility of a senior person? You see, this is a robot. So I developed this robot in 2010. Of course, a real human dancer can dance better than the robot. But dancing of robot was not so bad. Yes? So this means that now we have the technology to control the whole motion, whole body motion of a human. So we can apply this technology to make to assist the mobility of a senior person. That's the idea. So when we are getting old, so we can lose our mobility gradually. So at first, we could, our walking can be unstable and also can be slow. This state is called frailty or sarcopenia. So for such a state, so we have such a walking for assist for wearable walking suits. So and when we lose our mobility more, so we can use such a walking cart to support the walking. And then even when we cannot we cannot walk outside, also we can use a similar walking assist cart for walking inside the house. So finally, when we lost mobility, when we cannot stand up nor walking, so see we can use some robotic device to help it transfer between the bed, furniture, and the toilet seat. This is one example. So here, so this this madam is using a walking cart. Here there is a motor on the wheel, and motor can assist the power of the motion. And also sometimes so the person may use this gust with excess speed. So such excess speed can be detected by a sensor, and this is suppressed by using the motor brake. And also, motion can be stabilized when this person goes through a slope. by some smart control. And when also this cart is used outside, the walking trajectory can be recorded by using the GPS. And then we can evaluate the quality of the walking, like the speed or the stability or the length she walks. So this can contribute to keep the mobility of a woman. This is the automatic drive wheelchair. Of course, we have electric drive wheelchair for a long time. But unfortunately, you have many accidents when this such electric wheelchair is used outside. So we have a report of the accident. Such accident may happen. So when this wheelchair pass through the rough terrain or some gap and may fall down. So if such a wheelchair can be driven, so automatically we can avoid a dangerous place and can keep the safety of the users. And also, this is a transfer assisted device. Here, transfer can be assisted among the bed or the wheelchair or the toilet seat. In this case, this woman is transferred from the wheelchair to the special chair for taking a bath. This device uses multiple joint, instead of the single joint of the conventional device, and can provide a stable transfer between these places. And also, when this device is used, so see here, so the user can still use his own muscle for standing. So this can contribute to keep the strength of the muscle, so even to the very final stage. And this is a part suit for walking assist. Here, I show the small demonstration of this suit. So here, this is walking. The power is not assisted. Instead, the balance and the walking rhythm is assisted with powered suits. So this was the commercial product of Honda Motors. And Honda Motors have studies bipedal walking of a human robot, like that the dancing robot, for a quarter century. And they applied that control technology to develop this walking suit. Yes, so when I walk like this, so this the joint triangle can be recorded like this. So then this we can record such a data, so we can evaluate the quality of walking. For example, the rhythm or speed or the stability or something like that. And we have a Japanese national project to develop such devices for long-term care. And we have could launch 15 commercial products that include such a walking assist, also the smart toilet. Here, the waste can be processed to flushed to the outside. And also, we have several types of the transfer assist. Also, we have developed the safety surveillance sensor that can monitor the status of a senior person under care. And also, this slide shows the technical background of such devices. We have developed several simulator and modeling tools. The first one is the digital human model. It's a physical model of a human that includes shape, weight, everything over humans. And we had 50 subjects of around 20 years old, and 80, and 50 subjects around 80 years old. We have the digital human model for young people and old people. Using such models, we can visualize the burden and also pressure distribution when such a device is used by a senior person or the caregiver. And also, using such simulators, we can optimize the assist motion. You saw the transfer assist device, and that one has 2 degrees of freedom. It means we have the infinite number of the options for the assist trajectory. And using such simulators, we can find optimal trajectory. Optimality means that that gives the minimum pressure to the user when such assist device is used. We also built a safety center for testing the safety of robot. So in this center, we can test the collision avoidance or collision itself, durability, including temperature, for temperature, humidity, vibration, and also the dynamic stability of furniture can be tested on the slope, and also EMC test, and also finally the sensor test using the artificial sun. This is a light source that has the similar spectrum with the sun. So we can test the sensor devices using this light source when for the sensor is used outside. And the final question is that when is the AIST most effective? So we know that from the reality state, if we apply proper exercise to a senior person, and also we control for example, nutrition, so we know that most people can recover from the reality to the independent. But less people can recover from the more heavy state, like care state. And unfortunately, very few people can recover from the state under the intensive cares. So best time to apply such assist is in earlier stage. It's most effective. So we have to apply such assist in early stage. But I have to say that I talk about only robotics today because I'm studying robotics for a long time. But robotics is just one of many assists. For example, sports, physical therapy, medical rehabilitation can contribute to recover the body functions, and also health check, nutrition support, improvement of lifestyle can contribute to keep our health. And also this is most important, to keep the motivation to be independent and also to enjoy our lives into the final stage. So communication and also the social and civic life are very important to keep such motivation. So when we are getting old and also when we lost our mobility, many people may lose the motivation to keep their health and mobility and to enjoy our lives. So I want to say that family or friend are much more important than robot. So to live happier in the final stage of our life. So this is summary. We can enjoy our lives with more mobilities. Robots can assist the mobility of senior person in some situations. And also the assist is more effective in the early stage. So, and the most important message is robotics is just one of many assists, and you are much more important to your senior family member and friend. Thank you. That's it.